Carpet is probably one of the most technologically advanced things. What, you want to take clothes and put it on the floor? That sounds ridiculous, right? But now we can't imagine a world without carpet. You probably don't pay attention to it much unless you're an interior decorator or something like that. And so I was thinking about that from the point of view of a technologist, as somebody with technical skills, and I created this graph. That's right, all by myself. It charts the arcaneness or the rarity of a specific technological skill set over time. And so on the vertical axis we have how arcane is it, and on the bottom we have how long has that technology existed. When the technology first comes out, we basically must wield the forces of nature to do anything with it. There's a very few number of people who understand how it works, and those people are typically very valued and very treasured, right? As time goes on, things become a little bit more common, and in my point of view, I think the cloud is somewhere kind of in the middle here right now. And as time goes on and things become even more common, and we get to that point where we start forgetting about things, or at least not noticing them, that's when we get into Mario territory. Let's take plumbing, for example. Probably the most significant advancement in a whole bunch of different areas possible, right? I mean, running water, all that kind of stuff, amazingly important. But as a society, we've gotten to the point where not only is it so common that we don't think about it unless the water doesn't come out when we turn on the spigot, we also see the profession of plumbing as somehow lower than other professions, even though it's probably more vital than a lot of other ones, right? Lawyers or plumbers, which ones do you want, right? So not only has it become so boring that we had to take it and put it into a video game where the plumber kills dinosaurs. That also got boring. So then we had to put him in a race car so we could get excited about it again, right? And this is our lot in life as technologists. We build things that people rely on and people enjoy, and then they forget about them, and then they don't like us anymore, right? And it's because new stuff is coming out all the time. That's why this cycle happens. You know, Python's now the most popular programming language in the world. I learned today, actually, just a few moments ago, probably with all of you. I started learning Python about 5 years ago, and it was kind of arcane. I mean, it was still really popular back then. I had amazing tutorials. But it was my new hot thing. I moved from PHP to Python. And every few years, we get out this new technology, especially in the JavaScript world. We have, you know, all kind of JavaScript frameworks coming out. It's pretty much impossible to keep up with those things. But all this stuff comes out, and it's all exciting and new, and we collect them, and we get little badges of honor that we put on our LinkedIn profiles about them, because we want to be in with the cool stuff. We want to be one of those wizards. And that point in which we start to ignore it, or which it starts to become not as interesting, of course everybody's a Java developer, right? Is when it becomes a seamless part of your experience as a human being, right? You don't think about cameras anymore, unless of course you're into cameras. There's always an exception. But for the most part, the camera's just a thing you pull out of your phone that also, or you pull out of your pocket that also has a phone attached to it, right? It's just a thing, right? It's this seamless part of your existence, and you don't even really think about it until it reboots randomly, or you run out of power because you were playing too much. I don't know, where are people playing now? Temple Run? Is that what it is? So, and kind of the pact that we make with users of any specific technology is based on the idea that you can ignore it. You should have something that works so well that a person doesn't even have to consider its existence to even use it. It should just feel like a natural extension of their world. And that's the pact that we make. That's the promise that we make. Whether it's spoken or not, whether or not it's in your terms of service, if you throw an app up on the Play Store or you sell an application to a company, you're saying that these are the things that I'm going to provide you, and it's going to work all the time. Of course, hopefully it's going to work all the time, but that's what you're promising. It will work. It will do these things for you, and you don't have to worry about it. We're going to take this expertise. You don't have to worry about it. We're going to take it on for ourselves. And our goal is to make sure that they don't have to look down and think, what is it that is actually holding this whole thing together? And that, from an infrastructure point of view, that's what I do. I look at applications and I say, how does that match with the infrastructure that can power it? What are the different things that we can use to make that infrastructure solid? Interestingly enough, I have on a PF Flyer shoes. Anybody remember PF Flyers? Yeah. They were a huge company back in the 60s and 70s. They eventually got bought by Converse, and then there was an antitrust suit, and then the brand kind of died for a while. Now they're owned by New Balance, and they started back up in the early 2000s. What's interesting about these shoes specifically, not necessarily the ones I'm wearing, but PF Flyer in general. PF Flyer, anybody know what that stands for? It stands for Posture Foundation. Interestingly enough, PF Flyer was the first company, it was actually a Goodrich, I believe, was the first company to do a little bit of science on feet and figured out that a specific shape of insole could help make it more comfortable to run, to perform better. And of course now there's crazy shoes with water or air or whatever kind of crazy stuff those kids are doing now with the little pumps, the little lights, right? But I mean, it spawned an entire industry, just this one simple concept of if we slant somebody's shoes and we put the weight to the outside instead of the inside, they might be a little bit more comfortable. And that's kind of an amazing thing to think about. So how do we get there? How do we get from we have shoes to we have shoes with comfortable insoles? Let's take an example of something that at least everybody who came from out of town experienced in the last couple of days, which is checking into your hotel, getting your hotel room key. So we all know the traditional process, so I'm not going to bother talking about that. I'm going to talk about the dream, the hopes, the wishes. I walk into a hotel, I have a phone on me, most likely Bluetooth is turned on. There's some type of low-powered Bluetooth device sitting somewhere in the lobby, and it recognizes that there's another Bluetooth device that has shown up. It sees the MAC address, it says, hey, I know that MAC address, that's Phil Jackson, not the tall one, the short one. He seems to be here, great. Oh, look at that, he has a check-in today. Maybe I should see if his room is ready. Let's see what his preferences are. Okay, he doesn't like to be near the elevator, he has allergies, so don't put him in a room with feathers, which they actually put him in a room with feathers last night. It was terrible. But you have this whole process that we can walk through. And instead of getting a physical key, maybe actually it sends some type of token to your phone and you can use NFC. I mean, there's a whole lot of stuff that we could do. We could play around with this. And the idea is that we look at a user's experience when we're building an application or we're building a workflow. And we chart out all of the steps and processes that they have to go to or go through to achieve a specific goal. And then we figure out what those pain points are. What can we automate? What can we make simpler? Are there things that we can just not have the user think about at all? And that's kind of how we arrive at these wonderful applications, these wonderful devices that can be completely ignored. I mean, probably a year or so, if we had this hotel check-in technology, if we had it for a year, I mean, you would just be so offended if you walked into a hotel and had to talk to somebody, right? You would just be so used to going straight to your room. Think about all the steps that are required to start a car. Key in the door, hit the button, you sit in there. There's probably 30 steps involved actually in starting a car, but it's so second nature that it just kind of happens. And that's really what we're trying to build. We're trying to build things that are just so second nature that people don't even have to consider how they operate. But as builders of these things, as people who are looking beneath the covers a little bit or beneath the fold, we have to think about actually those pillars that hold up each one of these different portions of the application. Now, there are two primary ways I see to build things. This is one of them. It's what we used to call enterprise design, and that contrasts with this newfangled web scale or internet scale design. For the most part, I see it really as a difference in time between when we had cloud resources available and when we didn't. This enterprise or this older school design, the way I like to think of it is exactly how you would build a road. We look at peak usage of some sort. Let's say it's a mail server and we're going to have 30,000 users. We see how much traffic they're going to generate. They're going to send this many attachments. We have a whole bunch of statistics about it. They're going to work 9 to 5. We know a whole bunch of information. And we build this big old solution that's going to be able to handle that. And then for the most part, during all the off period, which is probably the majority of the time in this infrastructure's existence, we have wasted capacity, right? But then every once in a while, something like this can happen. This is actually a picture of Interstate 45 in North Houston. A couple of years ago, we had a hurricane, Hurricane Ike, I think it was. And the city of Houston kind of got on TV and was like, hey guys, get on out, it's gonna be bad. And so we did, we got on out. And this was the result of it. They actually, this by the way is a huge freeway. I mean, it's just massive. And what they've done is they've taken both north and south sets of lanes and put them all north so we could all run to Dallas, basically, is what happened there. And this was so bad that people were just leaving their cars in the freeway and walking because I mean, you were taking 4 or 5 hours to be 5-6 feet. I mean, it was just a terrible, terrible thing. And this is exactly what you don't want to do with your application. You don't want to build an inflexible structure that's going to basically cause everyone to abandon whatever they were doing and walk away from you. Because especially in the internet world nowadays, once that happens once, they never come back, right? It's especially if we're talking about a web application. You kind of get one shot at giving people a good impression. Yeah, I don't know about you guys, but if the link takes more than 2-3 seconds to load, I close it and just move on to the next 1,000 things that I can look at on the internet, right? So how do we do it? How do we get from, we have this application idea, we have this workflow or whatever it happens to be, how do we get to a stable infrastructure? How do we figure out what that is? It's all about TRTFTJ, hashtag TRTFTJ. That's a subtle hint to tweet TRTFTJ. That was a not so subtle hint to do it. So it's all about figuring out what the right tool for the job is. What are the things that I have available? What are the things that I can use to make my application faster and stronger and better and all that kind of cool stuff? So what we're going to do is we're going to take a little trip together. We've talked about cloud and we all have this amorphous idea of what it is. But I want to kind of peel back the onion a little bit. I want to look a little bit deeper. And let's look at all the components that actually make up these bare metal servers and these infrastructure that we have. So there's a couple sections we'll go through. The first one I want to talk about is compute. Now with compute, I think this is probably one of the largest decisions you have to make. And there are two primary types. You have bare metal servers. Now, bare metal server, as I said, is kind of how this whole infrastructure as a service cloud thing got started. It's a server without a hypervisor. It's that simple. A cloud box that we typically talk about on the public cloud is a server inside of a hypervisor, which is a virtual machine. Right? So a bare metal server has some positives, has some negatives, as with all things. There's no magic silver bullet. It's single tenant. If you're purchasing, of course, you can share a dedicated server with multiple people. There's single tenants, you don't have to worry about noisy neighbors and people making a racket at 4 a.m. or doing a whole bunch of database crunching and making your cat pictures not load properly. You can typically do a little bit more configuration with them. So you can say, I want this specific stick of RAM, or I need 6 hard drives in this specific RAID array. And those are some of the configuration ideas that you don't always get with virtual machines or public clouds. But in favor of the virtual machine, they can be a lot faster. They can be a lot more agile, particularly when we're talking about provisioning. Now, with agility, we get a pretty good benefit from being able to take these virtual machines, and if we've done a pretty good job architecting our infrastructure, we can bounce these virtual machines between different dedicated servers. So if there's a problem with a specific physical server, we're able to migrate that virtual machine to another one. Not a really huge deal, and we can really kind of roll with the punches. We also get the benefit of quick provisioning, and there are a whole lot more tools available to kind of play with virtual machines because of their current popularity than there are with bare metal servers. So there's definitely a lot going on for the virtual machine that the bare metal does not provide. Once again, it's really just a matter of what do you need. In storage, there are two kind of primary categories. The first one is local storage. Now, local storage means hard drives in a server, right? And this is something you have to consider, by the way, not only for bare metal machines, but also for virtual machines in a public cloud. Some public cloud providers have the hard drives local, some of them have them remote. This is something that you kind of have to think about. With local storage, there are two primary types of drive. One of those drives is solid-state disk, or SSD drives. The other is spindle drives. The best way to think about spindle drives is just like a record. You got a disk, you got a little arm that reads, makes sound. Same kind of deal, but instead of sound, it's magnetic instead of etchings, right? But that's pretty much how it works. So of course, really fancy drives have multiple platters and multiple arms. But all of that data has to go through this physical motion, basically. It has to physically seek that data on the drive. In the current paradigm, SSD drives typically have a smaller capacity. They're typically more expensive, but they're a lot faster. With with spindle drives, they typically have a lot more capacity. They're very, very large. They're slower, and they're a lot cheaper. That gap is definitely closing. We're starting to see prices on SSDs drop a whole bunch. Capacities are getting much, much larger. But it's still kind of there, and it's kind of a decision that we have to make on price, especially in the bare metal server. On a virtual machine, the real choice is between, do I want local storage with SSDs, or do I want remote storage on a SAN? You kind of have to think about it, but it's abstracted a bit because we're dealing with the public cloud rather than bare metal. The second type of storage is network storage. And there are three kind of categories of network storage. We have NAS, we have object storage, we have SAN. The best way to think about SAN, or at least I think the easiest way to think about SAN, is if I were to put a hard drive on that side of the room, and I were to put a computer on that side of the room, and I got a really long SATA cable and I ran it across the room. That's kind of how I like to think about SAN, except instead of the SATA cable, it's probably Ethernet or something like that. So it's working over a network, but it's block level access to a storage device. And block level access allows you to do a number of different things. Put your own file system on there. It kind of gives you a lot more control over the actual storage. It also it appears on your operating system as a hard disk, right? And you're able to move that hard disk between different hosts. This is one of the popular strategies when we were talking about taking a virtual machine and moving it across different dedicated servers or bare metal servers. This is one of the ways that you can do that. You have this SAN that's actually hosting all of the files and the operating system. And you just have these virtual machines mount these SAN endpoints to be able to start up the virtual machines. Now in NAS, you guys have probably all used a NAS before. This is basically a network file system. It's like the share drive you probably have at your office, or if you're at home and you're using Plex or something like that, that's normally working over a network file system, a NAS typically. Now, by the way, if you go and you say, man, that talk from Phil was awesome, I want to go learn more. If you go Googling these words, it can get very confusing because technically a NAS is a SAN, and technically a SAN is a NAS, and so it gets a little weird. But just power through, and it'll make sense if you dig deep enough. We're trying to keep it pretty simple with this one. Now, with that NFS, that network file system, you have access to files. Remember, at SAN, we have access to blocks, and at NAS, we have access to files. Okay? It's a small but very distinct difference. Now, with object storage, we kind of have something completely different. And object storage is a newer concept, at least newer in popularity. And the idea behind this is, at least kind of the way I process it, is if I have a mobile app or I have a web app, I don't really want it to have to care about SAN or NAS or anything like that. I just want to be able to store some files and easily deal with that. So object storage is kind of like a NAS, but it deals primarily through APIs instead of some more traditional protocols like NFS or ZIPs. It's very popular, especially when we're talking about mobile applications. Since it is API driven, it's really easy to integrate with those types of things. You don't have to worry about VPNs and doing all kind of weird stuff, right? It makes it a lot simpler to do stuff. They call it object storage because the paradigm's a little bit different. For the most part, we don't talk about files and folders, we talk about objects and containers. I'll give you a little hint, it's basically files and folders. Don't tell me I said that, I'll get some free. But so that's network storage. We have local storage, we have network storage, and this is something that's relevant for both virtual machines and bare metal servers. For virtual machines, Maybe you want SSD drives because maybe you're going to try to do a database, a low performance database inside of a virtual machine. And with dedicated servers, it's really a matter of what really do you need? Do you want a whole bunch of storage on some local disk drives really cheaply? Do we want to have some good redundancy? So maybe we should use a SAN because it can have hundreds and hundreds of drives and we can carve it up for different servers. There's a lot of options that you can look at. One of the last categories we're going to talk about is actually automation tools. And this is an interesting one because it's not so much specifically about the infrastructure itself, but more so about the tools that we have to manipulate. As I mentioned a little bit earlier, bare metal has kind of right now fewer tools, at least in the DevOps world, than virtual machines do. And the real decision here is not necessarily that Ansible's better than Chef. It's really about making sure that whatever infrastructure you do decide on has support for the types of tools that you want to use. And of course, this could also mean maybe I build it myself, maybe I extend SaltStack to support software's bare metal servers, whatever it happens to be. The important thing though is you don't want to have to be a slave to the infrastructure. You want the infrastructure to work for you. And these types of tools, they're becoming much more popular with the DevOps movement. And you want to make sure that you're taking as much advantage of those things as you possibly can. And from my point of view, probably the most important aspect of infrastructure is the network. I kind of like to think of the network as the infrastructure that holds the infrastructure together, right? Because it's the thing that allows us to transmit data from hither to yonder, hither to hither. Kind of like the trains. So I say that when I was a kid, I went to Galveston, Texas, and they have a train museum there. It's been closed down because of the aforementioned Hurricane Ike. It kind of destroyed it a bit. Very sad time. But I just remember as a kid going there, and they would have these kind of wax figures that you could walk up and hit a button, and it would tell you something interesting about the train that you're going on or something. I just remember this lady was talking about how fascinating it was that how quickly she could get from hither to yonder, yonder to hither. And that's how I think about networks. The best two analogies are either railroads or plumbers, really. I mean, at Software, I often think of us as kind of some of the world's best plumbers. Bandwidth equates to, or at least analogizes, if that's a word, to plumbing pretty well, to water. We have throughput that we typically measure in gigabits per second, right? So, I got a 10 gig connection. We actually mean 10 gigabits, not gigabytes. Gigabytes is a measure of storage, gigabits is a measure of throughput. And if you think of that throughput, think about how big the pipe is, right? So if I have a 10 megabit pipe, it's this big. If I have a 100 megabit pipe, it's about 10 times larger than that. If we think of it from a railroad point of view, we can think about cars and capacity, right? We can think, I can take a car that's, maybe a typical family sedan. I can pack it full of ramen noodles, whatever we're shipping, and I can drive it from Houston to Dallas in 3.5 hours. But maybe I can take a train and shove it full of thousands times more ramen noodles, and I can get it from Houston to Dallas in maybe 5 hours. But the amount of ramen noodles that I can't believe I'm doing an analogy about ramen noodles. The amount of ramen noodles that we've transferred is much greater, right? And so throughput is one measure. We have the tendency to call that speed, but that's a misnomer. It's not really speed. What speed is actually latency. Sometimes people call it the ping time. The latency is how long does it take for me to send a packet, one of the smallest forms of information that we send on the internet. How long does it take for this packet to get from hither to yonder, yonder to hither, right? That's the latency. And these two things together kind of determine the health, or at least the usability of a networking infrastructure. Of course, there's a lot more to it with redundancy and different types of routing protocols and all kind of cool stuff. But those are some of the primary things that you want to think about from an application point of view. Some apps don't really care about this. Some apps care about it a whole lot. It really depends on what you're doing. If you're doing YouTube, for example, latency isn't as huge of an issue as bandwidth is. I mean, they're both important, but if we try to balance them out. If we're doing stock trading, latency is probably the biggest issue possible because we're trying to beat other people by tenths of a millisecond to make that trade happen faster, right? So it's really a matter of what we're doing and how we're doing it that kind of plays into what are the important parts of a network. This also comes into play specifically with latency, and also to a smaller point on bandwidth, to geographical location. So if I'm doing a real-time gaming application, maybe I'm doing a first-person shooter, or maybe it's even Grand Theft Auto, you probably want users that are playing the game geographically close to each other, so the ping times are as low as possible. Otherwise, you get a whole lot of frustration, and people scream about lag and that kind of thing. And that can also become a real factor in, especially Southeast Asia for bandwidth. Some of the connections between those countries can be pretty poor or extremely expensive to get a large amount of throughput. And so you do end up in a situation from time to time where if you have an app that, let's say, it's hosted in Singapore, and you have a data center, you have a data center in Singapore, but maybe your users are in Kuala Lumpur, they might not be able to get a good experience even though it's not too far from each other. It's definitely closer to the United States. So you kind of have to think about that when we're thinking about who our users are, where do we want to have our data centers at, what's the latency that we need, what's the throughput requirements that we have. The network is the kind of glue that ties all this stuff together. We have a dedicated server in a room, but it's not plugged into anything. It's only useful to the people that are physically in the room, right? That's what this whole internet thing is about. It's a big old network. So let's take another little journey together. We're going to try to practically apply this knowledge that we have of these different tools to a real-world scenario. This scenario, in fact, is a video sharing site, like a tube for you, tube for you, maybe something like that. Now, I will point out that the original tube for you, their implementation is nothing like this. All right, this is something that I put together. Actually, it's just a demo application. But what I do find interesting is that I was actually I'm not going to show you the demo app because it's really ugly. But I was able to put it together in about a week. If I was trying to do this 10 years ago with only dedicated servers and without all these cool cloud resources that we have, it would have taken me months. Right? So I just point that out up front. But it's a pretty simple app. It's hosted on Drupal, or it uses Drupal as an application framework. One, because Drupal's cool, and also because it handles all the authentication and all the content management. It takes care of a lot of stuff that I just don't care about. I've decided to let Drupal handle that expertise. I need to normalize the video format. So somebody might be taking it with their iPhone. They might be taking the video with Android. They might have taken it with their Nikon. There's all kind of different file formats that the videos originate from. We need to transcode them into a specific format that I can handle. And then finally, we publish the video so people can look at the stupid cat video or whatever it is. So once again, the most important thing, hashtag TRTFTJ, we're looking for the right tool for the job, okay? So the first thing we do is we look at our map, just like we did with the hotel example earlier. We go through the process, but the important thing here is that instead of doing it from the user's point of view, we're now doing it for the application point of view. Typically, as developers or people that are kind of working on apps, even from a design point of view, we're really thinking about users. It's time to kind of look the other way. We're looking down instead of up, looking down the stack at what's actually holding it all up. So this is, maybe a 20% detailed view on the actual application. It kind of goes through a whole bunch of steps. We get the video in. We have to generate a file name, we have to locate the storage array, we have to do all these tiny little things. The actual map of the experience of the application is actually pretty useless. This isn't useful at all. What we need to do is take that big map and then segment it down into some simple, usable logical chunks. Some little units that we can actually do something with. All of those tiny little steps are really important, but from an infrastructure point of view, I don't care how you're generating a file name unless it's so complicated that we have to make something special for it, right? So, if we take a look at that same application from a different point of view, it's all the same steps, but we've containerize them into some logical units, this is what it would look like. There's 4 Drupal concepts, there are things that we have to do, 4 steps. And each one of them we're going to call a worker. And to pass information from one worker to another, we're going to use a message queue. Who knows message queues? Right? Message queues are pretty simple. Pretend you're British and think of a line. Right? That's pretty much it. First in, first out. The message can be any string. A lot of times people are using JSON or XML, something like that. Now, we have these workers, and these workers are basically, at least in my example, just functions. They're just PHP functions that I can call from a URL. So I can call each one of these workers individually. And these 4 steps are discrete, but they complement each other. So we create a Drupal node. We transfer the video to the transcoding service. We start the transcode process. We have another step to see if the job is finished, and then finally we publish that video. Now, how I decided to break these up was basically anytime I had a blocking process. So when I hit a point where I was waiting while doing this manually, kind of mapping out my experiment, that's when I said we're going to break it and we're going to do a new worker. What this allows you to do is have an application whose individual components are asynchronous, and they're able to run parallel, and they're able to run kind of regardless of whether or not the other ones are running, right? So if step 1 breaks, step 4 can still process any remaining jobs that happen. The other really cool thing about this is that we're able to take each one of these logical chunks now, and we can put them on different types of infrastructure. We can choose to have some of these steps on a bare metal server, choose to have some of these steps on a virtual machine. Now, if I was building this application 6 or 7 years ago, I'd probably do it like this. I have some web servers, they'd all be bare metal. We have some transcoding servers to build a little transcoding farm. We have some application servers. We'd have sand because you guys spent 40 grand on something. And probably soon into space, because space is awesome, right? But nowadays, I would probably build it more like this. In fact, this is exactly how I built it. I had one virtual machine, actually, that was kind of the center point for all of this orchestration. It was kind of the API endpoint. I built a little API, and that's where we make all the calls to. And all of these other things, content delivery, transcoding, storage, are things that honestly I did not want to care about. I wanted to build a cool web app that people could use. I didn't want to learn a whole bunch about storage. So this is, from what I see, is the big benefit of this cloud computing revolution that we have going on, is choice. I can choose to be an expert in transcoding, or I can choose to find a third-party vendor that can do it for me, that has the performance, security requirements, all that kind of different stuff. Why not pay them to do it? I'm going to have to hire somebody anyway. It's going to be expensive. It's just a matter of choosing, do you want to be an expert at it yourself, or do you want to rely on the expertise of others? And this could be either way. I could make this transcoding farm, I could make a global network, or I could rely on a CDN provider, for example, to do that for me. But in the end, this is your goal with all of this. You want to build an application so solid that you can have some guy riding a bicycle, not looking where he's going, just playing whatever game that you've created, mindlessly running into who knows what. And of course, if you've done it correctly, people probably won't even know that you exist at all. So thank you guys, I appreciate the time.